Okay, so for this one, so we have this thing, right? And what is it? Chlorine down here? Yeah. Okay, so we have this thing. So we're trying to figure out what reaction is going to happen. Okay. So we have a strong nucleophile and a strong base, and a secondary alkyl halide. If we look at our chart, it'll be E2. But if you think about it, we have a strong nucleophile and a strong base. Elimination reactions prefer strong bases because that's what's going to pull away these hydrogens over here. Okay, so if you have a strong nucleophile and a strong base, you're especially if there's heat, it's going to be E2. But whenever you have a secondary alkyl halide, strong nucleophile, strong base is going to be E2, simply because the nucleophile would have an easier time pulling off one of these hydrogens than it will attacking, given the situation. And we have a small base, okay? And according to Zaitsev's rule, if you have a small base, you produce a product with that, that is more substituted. If you have a large base, you produce a product that is less substituted. So they're kind of opposites. So like small base, more substituted, big base, less substituted. So we broke down the reaction stage, right? Strong nucleophile, strong base, secondary halide, so it's going to be an E2 reaction. So in order to figure out if this is going to work, E2 reactions, the hydrogens need to be anticoplanar to the leaving group. In other words, the hydrogens need to be trans in order for this to happen, right? So in this chair, right, basically we have this chlorine going down, this hydrogen going up. Also, sorry, these are called the beta hydrogens, right? These hydrogens are on the beta carbon. The beta carbon is a carbon that is directly connected to the alpha carbon. The alpha carbon is a carbon bearing the leaving group. The beta carbon are the carbons directly connected to it. On those beta carbons, you have beta hydrogens. And you're gonna, for elimination reactions, you're gonna want to pull those beta hydrogens off. Okay? And depending on the nucleophile you have, specifically the size, that's gonna tell you the answer. Okay? So let's go down here. Oh, and we see that these two hydrogens here are anticoplanar, right? This, and they're trans, right? This chlorine is going down, this one's going up, this one's going up, right? So it's gonna work out. Okay, so we'll have two options, but only one will be major, right? So we're looking for the major product. Okay, so right here I have our two options, right? First option is we're gonna pull this hydrogen off, okay, and that's gonna end up making this thing, okay. Second option, we're going to pull this hydrogen off, right? And that's going to end up making this. Okay, because what happens, oh, hold on, arrows are wrong. You pull the hydrogen off, and those bonds go down. Okay, so that's how we know where the bonds are. So now we move over here to our products. Okay, so we have two options. We have a product that is tri-substituted, right? As in, like, this double bond is connected to 3 carbons, right? Or di-substituted, right? This double bond has only 2. That's how we denote double bonds. Now, the question is, which one of these will be the major product? Well, the major product is actually going to be this one because of our base, right? Our base was small, Zaitsev's rule. Zaitsev's rule says if we have a small base, we're going to produce a product that's more substituted. So we have a tri-substituted product versus a di-substituted product. the tri-substituted product is going to be the major product, right? If this base was bigger, if this was a tert butoxide, then the di-substituted product would be major because it's the less substituted, right? So small base, more subs, big base, less sub. Sub is in the product, right? So that's how you do this one. You just break, when you do these reactions, you just break them down. What's the nucleophile? What's the halide? What kind of environment are we in? Then from there, you once you figure out what it is, if it's elimination, you got to make sure your leaving group, your hydrogens are anticoplanar. Once you go there, depending on the size of the base, you figure out what's the major or minor product.